Let's work a vapor pressure lowering example problem. In this problem, we're asked to calculate the vapor pressure of water at 90 degrees Celsius. I'll fix that. Should be a capital C there. 90 degrees Celsius for a solution prepared by dissolving 5 grams of glucose in 100 grams of water. The vapor pressure of the pure water at 90 degrees Celsius is 524 torr. So this is an example of a Raoult's law type of problem. We're going to approach it that way. Raoult's law says that the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. In this case, the pure solvent at that temperature is 524 torr given to us. So all we need to do is calculate the mole fraction of the solvent to solve this problem. So the mole fraction of the solvent is equal to the number of moles. In this case, the solvent is water. The number of moles of water in the solution plus the number of moles of water in the solution divided by the number of moles of water in the solution plus the number of moles of, in this case, glucose in the solution. All right, so we're given the masses. We need to know the moles in order to calculate the mole fraction. That's easy enough because we know that the number of moles is equal to the amount divided by the molar mass. And so for water, we have 100 grams of water, and divided by the molar mass of water is 18 grams per mole. That'll give me the number of moles of water, divided by the number of moles of water, which is the same 100 grams of water divided by 18 grams per mole of water, plus the number of moles of the solute, in this case glucose. We have 5 grams of glucose, and glucose is C6H12O6, divided by the molar mass. The molar mass of that is 180 grams per mole. So when I do the math here, I end up with 5.55 moles of water, and this obviously is also 5.55 moles of water. And this here is 0.0278 moles, 0.0278 moles of glucose. So if I calculate that, it's going to be mole fraction is going to be equal to 5.55 divided by 5.55 plus 0.0278. That's equal to 0.96. So that's the mole fraction of the solvent. And so the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent, which is 524 torr. That's going to be equal to 503 torr. So as predicted, the vapor pressure was lowered for the solution versus the solvent. Rather than using the change in vapor pressure equals mole fraction of solute times pure solvent, I went ahead and used Raoult's law directly. So I know that the new vapor pressure is 503. If I want to know how much it was lowered by, it's just 503, subtract that from 524. So the lowering here is lowered by 21 torr.